Hello from New York City and welcome to the Food Fix, Super Plants, Microbe Sidekicks and Nutrient Heroes. I am Eva Bosbach, Executive Director of the University of Cologne, New York office, and it is my great pleasure to welcome you all to our second Transatlantic Tandem Talk, part of a series held on the occasion of the 10th anniversary of the North America office of the University of Cologne. We host the series in cooperation with our partners, the German Center for Research and Innovation, DWIH New York, the German Consulate General, German Academic Exchange Service, DAAD New York, Deutsches Haus at NYU, 1014 Space for Ideas, the Goethe Institute New York, the German Embassy in Washington, D.C., America House NRW, Wunderbar Together, and last but not least, the German Research Foundation, DFG North America. And with this, it is my pleasure to hand the floor over to its director, Dr. Georg Bechtold, for his welcoming remarks.
The Cluster of Excellence on Plant Sciences, C+, is situated at the University of Cologne, and I welcome this opportunity to listen together with you to one of the PIs of this cluster, Professor Alga Zuccaro, and her colleague Mechthild Tegeder from Washington State University, as they tell us about a highly interesting subject that certainly will challenge us in the not so distant future. I'm pretty sure we have an exciting 57 minutes ahead.
We will now turn to our speakers and the topic, which is very exciting to me for two reasons. First, because both of our speakers are doing research on areas touching on truly global, essential questions, such as how are we going to feed 9 billion people on our planet by 2050, while at the same time protecting our environment. And secondly, it is exciting to me because this tandem talk is part of something bigger that we at the University of Cologne in Germany support with all our internationalization efforts, including our offices in China, India, and here in North America. We bring scientists and the interested public here from Germany and the US together to discuss cutting-edge research, to explore globally relevant topics, and to expand partnerships. Because just like plants, good partnerships grow. And so does the research collaboration in plant science between the Washington State University and the Cluster of Excellence C+ at the University of Cologne. We held the first transatlantic workshop on plant sciences here at the German House in New York in 2017. Subsequently, a delegation of graduate students from Washington State University attended the first international C+ summer school near Cologne. And today, this tandem talk is not only part of our series to celebrate the 10th anniversary of our North America office, but at the same time marks a launch of a new virtual seminar series between the two universities about advances that help feed and sustain our world. So here's Alga Zuccaro, Professor of Microbial Ecological Genetics at the Institute for Plant Sciences at the University of Cologne, and one of the C+ research areas coordinators, and Mechthild Tegeder, Distinguished Professor in Plant Molecular Physiology at the School of Biological Sciences at the Washington State University. You will hear from both speakers first, and we will continue with the Q&A session after the presentations. Enjoy.
So many thanks, Eva, for the kind introduction, and to all of you for organizing this event. And good morning and good afternoon. I'm Alga Zuccaro from the University of Cologne. And in this first presentation, I'm going to focus on the microbe sidekick. So I'm a PI in CEPLAS. This is the Cluster of Excellence on Plant Sciences, and I am the coordinator of Research Area 2 in plant microbiota, nutritional networks, and edaphic adaptation. Now, our mission in CEPLAS is to develop solutions for sustainable food security through excellent fundamental plant research. And we are deeply involved in training the next generation of plant scientists and in creating a highly qualified and active plant microbe research community. In CEPLAS, we want to understand and predict how plant performance and reproductive success depend on the integration of developmental decisions with metabolism, and this at different scales, and how microbiota contribute to plant performance and adaptation to specific environmental conditions. This includes also different soil types. Now, just to put our research into context, we are interested in plant microbe research because we strongly believe that this can contribute to sustainable solutions in agriculture. And as you know, the Green Revolution, which started in the 60s, enabled global food production to keep pace with the growing world population. And this actually was achieved due to important advances in breeding. And this was combined with heavy use of synthetic nitrogen and rock phosphate fertilizers. Indeed, the use of fertilizer increased by 800% from the 60s. This has, of course, negative consequences on the environment, especially considering the fact that phosphate is a non-renewable natural resource. So to feed the expected additional 2 billion people by the year 2050, which is over 200 times the population of New York City, and to achieve the Sustainable Development Goal number 2, which is zero hunger by 2030, we need to change our food production systems. So business as usual is not an option any longer, and to do things differently, we need to think differently.
Thank you, Eva and everybody for the invitation to present here in this great interaction on environment. And following Elga's presentation on the importance of interaction between plants and endophytes, I would like to address the plant side and talk about plant nutrient uptake, then the assimilation of the nutrients into a form that's usable for the plants, how plants transport nutrients to organs where they are needed for growth, as well as the importance of transport processes for plant performance and nutrient use efficiency.
Thank you. I actually had exactly the same question as Laura Rose in the beginning, but maybe as a follow-up, so you said that like then we have a high diversity in the soil. So how can we make sure that we then actually see the positive phenotype that we see, like if we only use the synthetic community? Don't you think that it will be like deprived then, not so active or something?
Okay, so they have to be, linked to this specific environment. So if you isolate synthetic, if you produce synthetic community from a soil which is, deprived of phosphate, then you will have an enrichment for microbes with functions in, delivering phosphate to the host plant. But of course, if you use the synthetic community on a field which has enough phosphate, the activity is not improved. So the idea of the synthetic community is to use, or biologicals generally, is to use them in environment where you have problems due to, for example, high fertilization or monocultures, and there is somehow soil erosions and deprivation, so you have already some issues. And this could be due to the fact that you are using already a lot of phosphate, or you're using plants that are coping well under these conditions with high nutritional input, but then suddenly you cannot use phosphate anymore, or you cannot use nitrogen for different reasons. So the idea is to help, the plants via the use of biologicals, and this should be integrative to normal and classical traditional farming, and is not particularly relevant probably in Europe, where we use a lot of fertilization at the moment. But if you imagine the situation in some in some areas in Africa, for instance, where you have really poor soil, then this will support the growth of your plants.
Okay,